3, 2, 1. And we're live. Awesome. Hey everyone, welcome to our, this is, I believe, the 24th online meetup. This time we're Dynatrace. We're joined by Matt, and today we're going to talk about monitoring and observability. So we're going to kick off, and we're going to learn about, the three pillars and how you can go beyond the three pillars by Matt's talk. And then I'll be sharing a little bit more about how you can reduce your cloud costs and follow all these best practices. So you can let us know where you're joining from, and this is being recorded as well and live streamed on YouTube. If you have any questions, you can utilize the Q&A section of Zoom and ask your questions live. Or if you're watching it via YouTube, you can just send in your questions in the live chat. All right, so we'll be starting with the very first talk by Matt. But Matt, before we get started, you want to give yourself a quick intro and get started with your presentation?
Absolutely. Let me share my screen here. You guys, let me know if you can see it.
Can see that, yeah.
Awesome. Well, guys, thank you so much for everybody from joining. Looks like you're on multiple different channels, so I feel a little bit famous today. My name is Matt Gibiec. I'm a senior solutions engineer with Dynatrace. What I will be talking about today is observability. Now, I do want to start with reading my title and saying you're doing observability wrong, breaking down the three pillars of observability. Now, you'll see if it's really three pillars by the end of the talk, but I really wanted to start in here with that little bold of a statement to really kind of open up your mind. And as I'm talking about observability today and what I think is the good approach to it, I would ask you that you maybe contrasted with the way you guys are looking at monitoring and observability today. And then hopefully I think that'll set you up for really understanding the angle that I'm coming from. With that said, just a little bit more about me before I get started. Like I said, I'm a senior solutions engineer with Dynatrace. I've been sitting in the observability space for about 6.5 years now. And on top of doing this for work, it's actually my passion. I really like the idea of having the digital world work perfectly, even though it's very hard to achieve. Okay. Now, with that said, I'm going to go ahead and get started. So the first thing that we want to talk about is what exactly is observability? And if you really think about the observability, and if I asked everybody on the call today, what do you guys think about observability? Maybe some of you will come up with these answers. Maybe some of you will say, it's an extension to monitoring, right? Monitoring has been there for many years, and now observability is this new buzzword, this new kind of concept that is new different tools and platforms that we use today. And some of you can say, I think it consists of three pillars. And the others might say it's a new approach for modern applications. Long story short, I think that observability at the end of the day can mean something different for everybody. Now, hopefully at the end of today's talk, we'll find a common ground. We'll kind of look at observability and it'll be on the same page. But I think to start with, an observability, it's almost like a personal experience on what you think about observability. The other thing I want to throw out there, if you actually type in observability into Google and go to Wikipedia, you'll actually see this. And then when I saw this, I was like, I think I need a PhD to really understanding what this is telling me, right? So again, there's a lot of different concepts tied into observability, and some of them are simple, some of them are more difficult, some of them are the hybrid of both. However, my favorite way of looking at observability is this. For me, what exactly observability is the ability to understand how your environment is performing through every single stack, through every single component in your environment, and being able to prevent this. So if you guys are familiar with this, I call it the spinning wheel of death, right? I'm sure you've experienced it before, where try to buy your favorite T-shirt, or I'm a huge soccer football fan, so I'm trying to buy maybe new cleats, or I'm trying to buy a new T-shirt from my favorite team, and I'm going to the website and I'm excited because it's 20% off, and I'm applying the coupon, and then I click purchase, and I get the spinning wheel. And it's spinning and it's spinning. So then I start doing something that we call rage clicks. And I click multiple times. And then it charges my card 10 times. Now, hopefully that won't happen. But let's say I'm not able to execute the transaction. And at the end of the day, this is what I like to think about when it comes to observability. It's the ability to understand how your entire ecosystem, how your entire environment is performing, to be able to come out with answers when outages and bottlenecks like this impact your users. If you guys are already in a model where you can 100% say, hey, when something is happening within my environment, within my application, when the users are impacted, I know exactly what it is, you guys are in a very good shape. If you're not there yet, hopefully through the rest of my presentation, I'll be able to walk you guys through, and from my experience, in my opinion, what's really needed to get to that level that we'll be able to fix things before our customers are impacted. So with that said, let's actually break down, right? This diagram that I gave to you, and I just said, hey, being able to fix problems before issues are impacted. But what do we really need to do that? What is the recipe for success in here? I think that originally it'll start with what was in the title of my presentation, the 3 pillars of observability. We'll have our metrics, and the metrics has been with us for a long time, right? We need to know the CPU and the memory and the response times and the throughput and all these different time series metrics. And they're absolutely very, very important. I think something that maybe has been even around for a longer period of time are logs. Those are definitely very important, right? Being able to actually understand what different log events we're triggering, what different logs are being generated by our applications, the transaction logs, the application logs, the system logs. There's a lot of, it's almost like a gold mine of information, right? There's just so much that we can find in there. Then we have still, I think, the fundamental pillar of observability, the traces, but a little bit newer pillar, right? Where now we are actually trying to look at these end-to-end transactions. So we're actually trying to look at, hey, as the user clicks something in the UI, that goes to my web server, to my app server, then to the database, right? Very simple flow, but I'm sure some of you still have those, right? Now that trace is also important. And I think for years, the conception there was that if you have these 3 pillars, the metrics, the logs, and traces, you have everything. Now I'm going to challenge it. And I think that in order to truly have a successful observability practice, you need a little bit more. One of the things that you need is events. What do I mean by events? Events could be coming in from environments like Kubernetes. They can be coming in from orchestration platforms like Ansible, right? It's essentially additional information. We can almost call the metadata about the things that are happening in your environment. And I think if we are able to bring events in between the metrics and logs, and also traces, we'll be able to have a little bit better, fuller picture of how the actual environment is performing. But what we cannot forget as well is the user experience. Because a lot of people like to say, start with the end in mind, or start with the goal in mind, right? So what does that really mean? At the end of the day, if you really think about your environments today and how you guys want those environments to perform like, at the end of the day, you guys are thinking about your customers, right? Whether it is an internal application or whether it is an application that is actually generating revenue for your organization because maybe it's a retail organization and you're selling things. At the end of the day, at the end of that or the front end of that application, there's a user. And it could be an internal user, could be an external user. If the application is having a problem, the impact to your organization, the impact to those users is different, right? But at the end of the day, that user experience is key in today's digital world. And last but not least, when I'm going to top this pyramid, this is now called, instead of 3 pillars, we're going to call it the observability structure or the observability pyramid. I'm going to top it with security. Now, why do I say security? If we were in person, I would now ask a question. I would say, hey, who in here works in security? And I'm sure a lot of you would think about it in a way, well, I don't really have a security in my title, so you're not going to raise your hand. But I'm gonna change a little bit. I think every single person that works in IT today works in security. Okay, why do I say that? Because it doesn't matter if your day-to-day job is to look for vulnerabilities or prevent SQL injections, or whether it's developing code or innovating your applications. At the end of the day, the security layer will be attached to every single task you do today. Because if you don't develop a good application that follows good security standards, even though your job is not security, you are now introducing a vulnerability to your environment that can expose your environment to hackers. So now you're obviously messing with security, okay? Now, I think if we look at this pyramid, right? So we have metrics, log, traces, UX, events, security. I still think there is something missing there, right? Think about it as this pyramid, right? If you kind of construct a building, right? You have all these different elements. But what I think you now need is for that construction, for that pyramid not to fall apart, is a glue. It's something that will keep all of that together. And that glue in observability is context. That is key. Having the ability to look at each of these individual metrics, traces, logs, UX, events in different perspectives, I think it's good. But at the end of the day, you need a unified way of being able to understand and analyze all this data, looking at it through the context of your environment, through the context of your application, through the context of what is important for your organization. Only if you do that, in my opinion, you will truly be able to become proactive with observability and start driving your business outcomes off of a true observability model. Now, what I want to do next, we're going to kind of dive in a little bit deeper into each of these, I can't say pillars anymore, at each of these components of our observability pyramid in here. So the first one is the one that, everybody's familiar with, metrics. And you can see in here, the metrics can be about infrastructure, and you can graph those metrics, and you can create those metrics using different tools. And you can have, things like CloudWatch and other cloud, essentially metric collectors, right? Whether you're using Azure Monitor, whether you're in GCP, right? It really doesn't matter. At the end of the day, there's hundreds of native or just tools out there that capture metrics. And some of them are a little bit better at creating dashboards, and some of them are a little bit more complicated. Some of them allow you to create prettier dashboards than the others. But remember, at the end of the day, it's still metrics, it's charts, it's what we call data on glass, okay? Now, next pillar of observability, logs. Definitely I almost want to say that this is what started the monitoring and observability practice, right? If you look back at when did really monitoring and observability start? I mean, I don't really know the date, but it's been a few good years, right? And I think that logs are really a true fundamental of the monitoring and observability practice. Even though we go to a lot fancier concepts today, like end-to-end traceability and traces and open telemetry and all that, at the end of the day, I think that you'll always find somebody in your organization that will ask you during a P1 issue, during a call that you're trying to troubleshoot something. Hey, what did the logs say? Did you find anything in the logs? And I think a very, very fundamental practice in here that we need to follow. And when it comes to logs, there's, today, obviously so many tools and so many different ways to capture logs and generate logs and query logs and extract data from them, right? Some of them, again, are a bit more robust. Sometimes they're a little bit more expensive that way. Sometimes, they're a little bit simpler, but a little bit cheaper. But at the end of the day, you have the ability to actually look at what you write into the logs. I always like to throw one more thing in here. For me, the one fundamental, not a problem, but a challenge with logs always was that you have to decide ahead of time. You have to decide ahead of time what you want to write in those logs. And when you're developing the application, I'm going to use this cliche statement in here, you don't know what you don't know. In other words, you can do an exceptional job creating logs and writing everything to them, but the chances that you might have missed a scenario that you won't log, so then when you try to create the logs during the issue, you won't find what you're looking for, okay? And I think I personally think this challenge actually introduced the concepts of traces into monitoring and observability. Because with traces, you don't really have to think ahead of time. It's the ability to trace the transaction as it is executing in your environment. It is the ability to actually understand that the call was initiated by clicking a search button, and then it went to the web server, and then it went to my Kubernetes environment that's hosted in AWS, so we're working with the EKS, and you know what? And at the end, it actually came back to the database that I'm still hosting on-prem, okay? So the traces now give us a better perspective, and I think a little bit better visibility into actual transactions and how those transactions are performing, which at the end of the day, I think that gets us a little bit closer to the user, right? To be able to understand what the user is actually experiencing. Now, again, when it comes to traces, so many different ways you can capture them. Probably a concept that you guys are familiar with, open telemetry, right? One way of doing that. There's also a lot of platforms out there that can capture traces today as well. Now, I say that because I actually want to call out that just a little anecdote I want to call out in here. Dynatrace, which is the company I work for, right? I've been with Dynatrace for 6.5 years now. We are actually the ones that started distributed tracing. So believe it or not, but the core of our development team, that is a pretty big team at this point, actually patented distributed tracing when it actually first was developed, and the people that actually came up with the concepts and the idea were the Dynatrace employees. Now, I have to share this one last thing in here. I love what Sonia said in here. Distributed tracing before it was cool. That's what Dynatrace did. I don't know, maybe it's my generational thing, but there's a saying in our generation now that, doing something before it was cool, right? Like before all the TikToks and the reels on Instagram and came out and things like that, people were actually doing things that now are famous on TikTok. So if you see it, you can say you were doing this before it was cool. So I like Sonia's comment in here that Dynatrace actually did distributed tracing before it was cool, which now obviously is a fundamental piece or component of a successful observability practice. Now, those are the three pillars that we started with, right? Those are the true fundamentals that we need for observability practice. But remember, I built that pyramid for us, and I actually enhanced it with a couple different ones. Events. Let's talk about events. I think those are very, very important in terms of adding context to what your logs, traces, and metrics are telling you. Being able to understand that a certain metric is spiking because there is a deployment event happening in your environment, or because maybe there is a VMware migration event happening in your environment within your VMware infrastructure, right? Events, very broad statement, but you can really now add another layer of visibility into your environment by capturing all these different events from the different tools and platforms and even orchestration platforms like Ansible, that you can now add and enhance that data that you need to really understand what your environment is performing like. Two more pillars that we have left in here. User experience. Again, start with the end in mind, or start with the end goal in mind, right? User experience is what we all want to go after. I'm sure that, at least most of us that are here are participating today would say that your goal would be to have absolutely perfect customer experience. No outages, no problems, no bottlenecks, everything works within half a second. Nothing ever fails. Users are happy. They're spending money, right? Our internal users are happy if it's internal applications. Nobody complains about IT, and then none of us would have a job. So maybe we don't want that. But I think you get the idea, right? User experience, again, super, super important when we talk about observability, because if we do everything perfectly in middleware, in the backend, but we don't consider the user experience, well, you might think you're doing everything perfectly, but how do you know how that is actually impacting your user? So that is where you really need to start to understand, how are the users using your application? How is the application performing for your users? That can now derive for you the next actions, the next items that you will have to go after in the middleware or in the backend of your environment when you design, innovate, and fix things. Right, and last but not least, another tangible component of our observability practice or successful observability practice needs to be security. Like I said, whether you have a security word in your title or not, I think if you work in IT space today, even you could probably go beyond that, but let's just stick to the IT space for now. You definitely are working in security. I just mentioned a couple of different things in here, right? Like third party, log4j, phishing, social engineering, cloud security. Those are, again, just kind of buzzwords that wrap the security, but I think it really shows us how big security is today, right? You working in an IT organization and really talking about observability and monitoring, having the ability to keep security in mind as you develop, as you test, as you troubleshoot, it's super, super important. Because if you design an application that's not secure at the core, at the end of the day, you might find yourself spending hours, days, or months on fixing something that you could have been done right to start with if you had that security concept in mind. And so I just mentioned all of the components of our observability platform. Now, hopefully you guys remember what's missing. In order for this observability pyramid for us not to fall apart now, what we need, come on, is the glue. We need the glue. And context, again, guys, is the glue. Always look for context. I mean, this morning I was on a call with a customer, and their question was, we were kind of talking about troubleshooting, and the question was, hey, I really just want to have like a dashboard with like all of my databases. I have like 50 databases, and I just want like a dashboard with all my databases. And I asked them why. And the answer was, well, because, if there's an issue, then I just want to have like charts, so like I can look at all this data and see if everything is performing fine. Okay, but where is the context in here? There's no context in here. All these 50 databases are not serving for the same application. If you know that certain application is having a problem, why would you look at all 50 databases in your environment? You need that context so you can dive in onto the specific microservice or the service that is serving content for this application. Now you're so much closer to actually figuring out what the issue is rather than looking at dashboard of 50 databases, right? So again, having the ability to apply context of your environment, of your applications, of your users into the observability practice is key. Now, how does all this observability practice actually translate into your environments, into your applications? And I think this will be a good explanation. Now, let's talk about the applications in the past and maybe the applications that you have now or you'll be dealing with in the future. For years, IT organizations have been based on what we call the monolith or monolithic applications. Right, what these applications had, right, was super easy, just an application running on like a one server, and you kind of could pull in all of those logs and metrics and traces from that server, and you were in, let's say, a decent shape, right? The environment was not that complex, so even if it took you a few hours to figure out, what's really happening, what's impacting the users, it was not that big of a problem because you knew that this application is contained within this one little box, this one little server, or maybe just a few servers. But what happens when you go to this world? What happens when you go to the world of microservices? When one little box is responsible for performing one little task, but it can also trigger a number of actions, a number of transactions across the entire environment, across the hybrid environment that could be on-prem, it could be in cloud. And at that point, if you don't have the ability to understand every single little detail about your environment, you will struggle. Because if you just have logs, I promise you'll miss out on a lot of content. If you just have metrics, the same thing will happen. So the idea now is that in order to be able to manage these complex environments that are on-prem, on cloud, and multi-cloud environments, you have to have a successful ability that will apply all of the context, all of the fundamentals of observability that we just talked about, metrics, log, and traces, but it will also enhance it with events, with user experience keeping in mind, with security, and the context of your entire environment that you're looking at. Now, there's a couple different ways to apply a successful observability practice to a microservices-oriented environment, okay? There's one thing I can tell you for sure. Keep status quo doesn't work. I've seen this. Like I said, I've been doing this for not a huge amount of time, but I think 6.5, 7 years is long enough that status quo doesn't work. Status quo doesn't work for modern environments when things are getting too complex, right? Just basing decisions off of metrics, logs, and some traces and being all that dispersed, it doesn't work. Now, there's two approaches that I have seen work. One of them is do it yourself. I think it can definitely be a successful approach, but I'm going to add a little but in here. There's a but in here. Because at the end of the day, even though you're working in IT, at the end of the day, if you think about the responsibility of your job or what do you do in your day-to-day basis, right? Let's say you develop applications, right? So your job is to develop an application because this application needs to serve a purpose to the organization, needs to serve a purpose for the user, and hopefully be tied with the revenue that the organization is generating. But your job is not monitoring, right? So if we really think about doing things yourself, you can start implementing different concepts like OpenTelemetry and start extracting the different data from your environment. But at the end of the day, if you're the developer, you will find yourself basically developing two different applications. The application that is actually tied into generating revenue for your environment, and then another application, quote unquote, monitoring or observability application. And at some point in that life cycle, you'll have to make a choice and say, where do I spend my time? Do I enhance that monitoring and observability application? Or do I spend my time on the actual application that my boss and my boss's boss needs to see because that's generating revenue for my organization, okay? And I think the answer always will be, you'll have to go with your application. And then what happens? The monitoring gets dropped until there's an issue, right? And then what happens? We don't have all the necessary data, all the answers that we're looking for. Now, the alternative to that one, especially in complex environment, is to leverage a platform. There's definitely platforms out there that focus on monitoring and observability, obviously Dynatrace being one of them. I think that is a safer bet for you because you will be in good hands as there are issues and bottlenecks happening in your environment. Because what we do, what the observability folks do in that space, our job is and our mission is to help you have applications that don't have any issues for users. And if there are issues, we want to help you catch them and troubleshoot them before they impact your users. Now, when you talk about actually the two different approaches that I talked about, right? So if you do the do it yourself, I think eventually, I think this is a perfect slide to talk about. If you do the yourself approach, you'll end up in this kind of world, right? You can see there's a Nokia phone in there. Yeah, I'm young, but I know what a Nokia is. So you'll end up in this kind of stitched together like a phone and GPS, and I don't even know what the device in the middle is. So maybe I'm not that, and maybe I am really young. But you essentially end up in this world of like stitched together different tools, and that kind of feeds you a unified information, but not really. And sometimes it works, sometimes you're still missing data. Or if you go towards leveraging a platform, I think you can shift from this Nokia kind of gemmed out, device into a brand new iPhone or Android phone if you're not an iPhone person, right? And I think that is a better approach because you'll get the ease of use, you'll get the solution to your problems when you need them. Okay. Now, if you do go to this automated approach where you can actually leverage an observability platform, there's a couple of things that will change for you. One thing that I think that will change for you is, I'm sure everybody's familiar with this picture in here, right? So it's essentially an AI apps, it's essentially a command center in here where we're monitoring, and they have all these different screens out there. And when things go bad, right, it's red on the screen and we can start troubleshooting it, right? But I think that at the end of the day, we can see that that's a very old approach. That's, if you can see the dinosaur in here on the screen here, that's a really old way of just looking at charts, all these different screens and dashboard, right? And if you just do that, if you stay in the status quo, or if you start to kind of implementing your own approaches to observability, at the end of the day, you'll still end up with a bunch of data on glass that you essentially will have to look at, like this dinosaur in here, try to figure out where the issue is and what you need to do to fix it. And that will still introduce to you guys exactly the same problem, right? Where I have my environment in here and I think I have a good observability practice, but at the end of the day, my users experience, my user is seeing that. Now, if you do decide to take that, take the leap of faith with me and take that step towards a unified monitoring and observability practice and approach that follows all of the different pillars and all of the different components of observability that we talked about, I think you will be in a pretty good space to be able to understand how your entire environment is operating, how it works, and find answers to your issues before they impact your users. An example of a platform like that in here is Dynatrace, right? And I said there's obviously some platforms out there, but I think that is a very important to understand that when we talk about an observability concept, an observability platform, a platform like Dynatrace is able to bring all of that to you into one picture. You can see that we'll bring in the infrastructure, right? So your CPU and your memory and your storage, and we'll look at your application microservices, whether they're on cloud or on-prem. And then that platform will implement security in the core of it. So we'll look at the application code. Do you have any vulnerabilities running in there? If there are, can they be exploited? Do they have public internet exposure, right? We'll attach that metadata in the middle of everything that we're already pulling in from your environment. We'll then enhance it with the digital experience and business analytics. So you will now be able to start with that end goal in mind. When you actually be able to understand how your users are using your applications, how the application is performing for users, and help you drive better decision-making from the development perspective to see what you need to focus on. Okay. Now, if you guys are able to follow that approach and really trust in the observability concept with the platforms that are out there, what I think you guys will end up with is you'll be able to switch this screen that you have already seen into this screen, where you will be able to simply see that the user was able to actually buy their t-shirt. So I'll be happy. I'll be able to now go out there and buy my soccer t-shirt without having, without looking at the spinning wheel of death in here. I'll actually be able to go out there and be a happy customer. You guys will be happy developers, happy operation folks, because your applications are generating revenue, because you're not having many problems. Now, one last thing that I want to add in here before I kind of open up for questions and pass it on. If you take that leap of faith and go towards that observability practice, you're trusting one of the products that is out there. This is just an example of outcomes that you guys will be able to see. Right? So this is just some of the probably well-known companies that you guys are familiar with, but you'll be able to see things like fewer support tickets. You'll be able to see things like greater operational efficiency. You'll be able to see things like higher card value, right? And not all of these might apply to you, but the idea in here is that if you have all the data that you need and you are empowered now to drive your decision-making and have answers from that data, instead of just having data on glass, with a true observability practice or a true observability platform, you will now be able to truly see benefits in your organization, in your IT organization day to day. So with that said, that is my little 2 cents in here in observability. I definitely want to thank you guys so much for your time today. There was a lot of talking for 30 minutes, but I hope you guys enjoyed it. Here's my email address. If you guys want to reach out to me separately to ask any questions or kind of, I'd love to discuss them. You can also find me on LinkedIn. If you disagree or agree with anything I said in here, I'd love to kind of engage in a conversation with you. But with that said, I'll pass it on to our moderator in here. Thank you, guys.
Thanks for sharing, Matt. And we definitely have quite a few questions over here. Quickly, the one followed up on like Dynatrace itself. Someone was asking, how does it compare with something like Elastic and other tools? Does it offer more of like an infrastructure level view, or can you even go more granular, maybe with more labels or tags or something like that?
No, I think that's a very good question. If you look at a tool like Elastic, right? So I'm sure you're probably asking a lot from the log perspective. I think that the true power of Dynatrace or the comparison in here with Dynatrace is that Dynatrace will be able to not only focus on logs, right? Or not only focus on just one portion here. We'll be able to pull in your infrastructure. We'll be able to pull in your applications. We'll be able to pull in how the users are using your application. And at the end of the day, one thing that, we didn't talk too much about Dynatrace, but at the core of the Dynatrace platform, we have an AI apps engine. That AI apps engine actually will be able to look at everything that we are capturing around your environment. And as soon as we see bottlenecks and problems, it'll be able to automatically kick off a root cause analysis. So what I like to say is when you shift to a model that Dynatrace applies to the observability world, you actually will be able to come in to Dynatrace and look at answers rather than just data on glass. So a lot of the troubleshooting and a lot of the time that you'll be able to save through that will be done by Dynatrace versus Elastic in here. Hopefully that answers the question.
Yeah, and another comparison question is around Pazler PRTG, and what would be the main differences with that?
Sorry, what's the product name in here?
It's called Pazler PRTG. I've not worked with it before.
Okay, I actually am not familiar with it as well. It kind of sounds similar to me as a network monitoring tool that I've seen in the past, but I'm not actually familiar with that. So it'll be hard for me to give a true comparison simply because I'm not familiar with that tool. But I'll definitely take it as homework. So if you grab my email address, feel free to or engage with me on LinkedIn on email address, and I can answer that way.
Yeah. One more question is around with all the folks moving now to a multi-cloud environment, being more dynamic, it makes it a little challenging to implement the observability systems. So there's this infrastructure complexity. So how do you deal with that?
That is an absolutely excellent question. Whether it's a hybrid environment, whether it is a multi-cloud environment, right? I think I'm actually going to steal it for the next time I do this presentation, but that's exactly why the do-it-yourself or the keep status quo approaches are very hard to be successful in. Because then you end up with, let's say you are between Azure and GCP and AWS and on-prem. Each of them have kind of built-in different monitoring tools, and on-prem you can deploy something else. But if you don't have a unified way where all of the data gets pumped to, where you can perform all that analysis, at the end of the day, you will still find yourself looking at 60,000 different alerts. You have an alert storm. You won't know where to look. You know how the problems are related. So at the end of the day, when we really talk about complex environment, I think that the best way to approach those is to actually leverage an observability platform, like, for example, in this case, Dynatrace. Because within Dynatrace, you will be able to capture this data within Azure, within GCP, within AWS, within VMware, even though that the transactions might be going through each individual component individually, we'll still stitch it for you all together. So if AWS is failing, we'll point out for you right away, hey, your API gateway in AWS is failing. So that way, that's impacting your transaction, that's impacting your users. Hopefully that answers the question.
Yeah, and while we're talking about it, we talk about scalability, then we talk about observability, just the amount of volume you get, when it comes to data, and you're having like various tools to build your dashboards and stuff. So how do you handle such a large amount of data in terms of, like, maybe let's say if you have static dashboards that are, having thresholds that are human generated, might not scale really well with modern environments. So when we talk about stitching up all of these pieces of information together from multiple dashboards and timestamps and all these other data sources and the alerts and everything, how do you not lead to a system failure, maybe?
Another very good question. And I think the only answer to this question is automation, right? When you have, and when I repeat it again, automation. When you have so much data, and I think a word that, or a phrase that everybody's familiar with is data on glass. If you have so much of these dashboards and you create all these different dashboards and put all that data there, eventually you just hit like a wall and you say, enough is enough. The environment is way too big to create all these dashboards. Now, what you need instead is an automated approach that will be able to pull in the data, analyze that data, predict what the performance of your environment should be like, and then if the real-time performance deviates from the baseline that it's being predicted, will automatically open up for you problem cards. And the answer to that is in AI apps. I think another component that you guys will truly see being introduced into the observability practice is AI apps, because that automation will be absolutely key when it comes to very complex environments. Instead of having you create all these dashboards and doing ad hoc analysis of all this data, let the AI apps engine take care of that. So when you guys are coming to this observability platform, you essentially get an answer. You know who's impacted, you know how they're impacted, and you know what caused the issue in the first place.
Amazing. And there's one popular question. Can observability solution replace monitoring platforms like Prometheus? I just like to start, like, I think monitoring observability, it coexists. But maybe Matt, you want to give a more detailed explanation.
I think you're absolutely right. And I honestly, I think that Prometheus is a part of, so Prometheus, right? If you use Prometheus today, you can essentially pump logs or metrics using Prometheus. So if you think about this, what are logs and metrics? They're fundamentals, right, of our observability pyramid. So I think that when you already have successful monitoring approaches in your environment today, it's not that you have to rip and replace and just get rid of everything you've had. I mean, if something works, you can absolutely make it part of your observability practice. So Prometheus is a great example. Even though that you move towards a platform approach, where you have a platform with an AI apps engine that provides you a lot of insights, but then you have this Prometheus component in here that already has a lot of the data that you know is important to you. Not a problem. Feed that data into that observability platform, and now enhance the analysis that the AI apps engine is performing for you with that observability data or the monitoring data that is coming in from Prometheus. So I think coexisting is absolutely a very, very common scenario. And to be honest, in many environments, I think it's key to a true successful observability practice, having the ability to marry everything that's working today in their environment with the new and greatest and automation ways that you can deploy.
Couldn't agree more. Thanks a lot for sharing, Matt. Yeah, more like just like in a simple example, like something goes wrong, monitoring would be giving you an alert. But if you want to look into the inner workings of the application and what went wrong, do a deep dive, find the root cause, observability will help in that case.
Yeah, absolutely.
All right. Well, thanks a lot for sharing, Matt. And by the way, Matt's talk was being recorded. Mine will be recorded as well. So I'll publish as separate talks on the YouTube channel later on, so you can watch it But yeah, I'm just going to start my quick talk. We have like around 20 minutes remaining. So hopefully you can see my screen, my slide. Can you see it?
We can see it.
All right, cool. So welcome everyone. We're going to talk about Kubernetes host monitoring best practices and about me. You can find me on Twitter, and I work as a development manager here at Civo, and really excited. So before we get started with like some of the best practices, let's talk a little bit about the challenges. So you're going to see a lot of memes here, but if we look at a recent cloud provider survey that we did, so we surveyed around let's say 100 companies using hyperscalers, and 45% of the firms indicate a growing pressure to reduce their cloud costs, and 37% have been stung by like unexpected costs in the last 12 months. If you're one of these, let me know in the comments. And yeah, 34% felt like they're locked into their cloud. So for example, egress charges and things like that. Around 65% said that it's expensive for them to leave. And we spoke to them about what is the top reason. So they cited that almost half of them believe that cloud providers outside the big three are, let's say, less secure. And 47% believe that they will suffer more outages, which, as we have seen in the news, it's not always true. But if we talk about the challenges, the first one, as we can see here, is inability to track cloud sprints. Now, as we were talking about in the survey, the sudden bill or cloud sprawl, which is a constant problem that many enterprises encounter. This basically occurs when a company is unable to thoroughly track and evaluate its cloud computing resources. And it refers to the sudden increase of cloud instances or cloud services or even providers. Another challenge, and I love, Matt, if you can share any challenges you have faced as well. But yeah, another challenge is a conflict between teams. So that's another one, because managing cloud resources and cloud costs, it shouldn't be, ideally should not be handled differently by every team or department inside the firm. If we talk about the tech team, they are focused on building the best version of the product, so they're making it efficient and using all the resources at hand and making sure that's like they're doing the best they can. But that in turns means, let's say, increases the price of your resources and your cloud bills and whatever. And then the finance department or the financial people, they're like, why has the cloud bill increased and things like that. Another challenge is over provisioning. So like acquiring more resources than the enterprise actually requires to support the workload of the organization. This is known as over provisioning. This basically results in wasteful use of cloud resources and unforeseen, like sometimes unnecessary costs basically. The next one most people can relate to, which is complex billing. So cloud bills, oftentimes you may see they are like unintelligible for like the finance department due to all the technical complexity and the jargon and all these other things. So it's also one of the key issues when we talk about what are some of the challenges that people face. Something that Matt already discussed, which is monitoring. Whenever someone asks me, how do you set up a good practice for reducing your cloud bill and things like that, my cloud costs. So it all starts with monitoring. You can't fix something you don't know that exists. And I'll talk more about monitoring later. All right. Now we talk about what are the goals? What are your goals? Let's talk about that. So we talk about the goals. The goal here is to reduce costs while maintaining the same speed of rendering and quality of service. It's not like you want to reduce costs and you make your product garbage. Okay, you want to reduce costs, shut down everything. Obviously, it's pretty self-explanatory. So think about your organization. How is it currently operating in the cloud? Does your enterprise have like a well-defined operating model? Have you formalized a FinOps organization? And it does not have to be complicated. Cloud cost optimization, that does not have to be complicated, but it requires a disciplined approach that establishes good right sizing habits and continuously you can drive insights and actions through analytics. So obviously monitoring plays a huge role here, and then you can lower your cloud bill. So that's what we're going to talk about today. So best practices. So let's let's start with that. If you have any, feel free to comment, and yeah, always open to learning new things. So first one, think about how cost monitoring tools work. So essentially, when you talk about monitoring tools, like cost monitoring tool, it's like a translator between the resource consumption and the cost. An example, this can be if a pod consumes like 50% of a node in an hour, it will cost 50% of that node's cost. Just an assumption. And the Kubernetes monitoring tool, like they act as a bridge. Someone's mentioning about Prometheus or like Datadog or whatever other offering like deep monitoring solutions for Kubernetes. So you talk about Prometheus, you can get like very granular consumption metrics. So these Kubernetes monitoring tools, they act like as a bridge. And when you talk about cost monitoring tools, then you have to also consider, let's say, the node cost. So for example, the cloud providers, APIs, and all these other things, and just need to decide how the cost is split between CPU, memory, etc. And when you join these things together, you will get the result of the cost per pod, and then you can, sort of like check out the building blocks of like these smaller entities to build more complex entities. For example, of this can be you can have you can have it grouped in like maybe cost per deployment, cost per namespace, cost per cluster, and something that is also a little bit like when we talk about it later, cost per customer. So you can make use of labels and try to see which customer is spending more with you, which customer is spending less with you, and things like that. All right. Second best practice is set budgets, right? So set budgets within, because it has you have a clear communication with the finance department, like, okay, this is what we have on our roadmap, this is what it's going to cost, and this is what we're planning, this is how much ROI it has if we have this feature out, and this is how much we're going to make back, and this is how much it's essential to spend. Let me also talk about some of the most common ones where people waste money. So unused and unattached resources. So if we start with the easiest way to optimize cloud cost, which is to look for unused or unattached resources. Now, for example, oftentimes an administrator or like a developer might just spin up a temporary server to perform a function, and then they forgot to like turn it off when the job is finished. And another common use case, the administrator may forget to, let's say, remove some storage that is attached to instances that they terminate. This happens frequently, and if you can relate, then let me know. And oftentimes you may have seen on Twitter also, I saw some people like, hey, I was just trying it out and now I have a huge bill. So yeah, so this results, that your cloud bills would incur charges for the resources that you purchased, but you are no longer using. So a cloud cost optimization strategy should start by identifying these unused and completely unattached resources and removing them. So we're starting with very obvious things and very simple things. Another simple stuff is idle resources. So idle computing instance might have, let's say, a CPU utilization of around 5%. And when an enterprise receives a bill for like the 100% of that computing instance, that is a huge waste. So a key cloud cost optimization strategy also would be to identify such instances and to consolidate computing jobs onto, let's say, fewer instances. You can also make use of reserved instances. So these are prepaid compute instances that offer significant pricing discounts. And when you're purchasing reserved instances from a cloud provider, you can select an instant type and like a region or an availability zone, and you can commit to using it for a period, let's say 1 to 3 years or whatever like that. And because you commit, most cloud providers, they offer like discounts of up to like 75% or whatever. One thing you have to keep a note is, because you're paying upfront, you have to do your research and pay and plan basically based on your assumption of how much you're going to consume. My question to you is, like, if someone asks you, talk about 1 year down the line, do you have an estimate on how much you're going to consume? So how would you answer that question? The answer is very simple. Maybe Matt?
How about observability platform to help you predict what your environment looks like and how it's performing at load and how you need to adjust it for moving forward?
Yeah, exactly. So check the historic data, right? And again, observability plays a very crucial role. And yeah, exactly what Matt said. So let's move forward. Spot instances. Unlike reserved instances, these are available for like last minute purchases. And this is not always very like reliable. So they can sell out pretty quickly. But yeah, the way it is different than reserved instances is because, they are available like for auctions, and it can sell out pretty quickly. So if the price is right and you want it for immediate use, you can use that. So Amazon has like some spot instances that are ideal for like web services or other stateless or fault tolerant workloads. All right. Next one is, this is an interesting one, heat maps. So heat map is basically, as the name suggests, is a visual tool that shows peaks for your computing demand. And you can utilize heat maps, to establish like a start and stop time to reduce cost. So for example, when you talk about development servers, so if you don't work on weekends, then development servers would be like, heat maps would indicate that, okay, development servers can be safely shut down during the weekends, for example, or things like that. When Super Bowl is coming, or when Amazon sales are coming, and you have, it's a huge spike. So a lot more people are using. Christmas is a very popular time. All right, now the right size. When you think about how do you figure out, it's difficult, to size instances correctly when you have more than like millions of possible combinations to choose from cloud providers. And in addition to your server sizes, you can also optimize for like memory and database and computing and like graphics and storage capacities and throughput. I'd actually love to hear, Matt, about, the right size of your instances. How do you pick that? How do you approach this?
I think first of all, that's a very loaded question. But I think the best way to actually figure out what the right size is to really understand what you're trying to accomplish on any given application, right? So as an example, right? I mean, historically, I see it all the time when we go into the customer, we start working with them, and then they have servers with 128 gigs of RAM. And then you look at it and then you're using 5% of it. Well, like 6 months ago, there was a problem. So we just threw some more RAM at it. I mean, didn't really fix it, but we didn't take it away, right? So I think at the end of the day, what we need to do is we need to go back to, as you design your environment, really understand, okay, what am I going to be running in here, right? What's the predicted workload, right? And I think that very important or very helpful analysis in this case could be like what we talked about before, historical data. Let's understand, how many users do I usually have in this application? What are the peak times, right? That will help you now design what model should I go? Should I go with auto scaling? So maybe I can run smaller instances, but I'll just run more of them as the traffic comes in. As the traffic goes again, I'm going to auto scale to a lower number of instances, right? So I think loaded question, but I think really understanding your environment and the load that you're trying to manage on it will be very helpful, especially using that historical data.
Yeah, you can also try having different size nodes. But definitely what Matt said, I couldn't agree more. All right, another one is software license costs. So software licensing, major component of cloud operating costs, and like manual license management is challenging, and it also increases the risk of paying for unused software licenses. So you can find like some of the license tracking tools to find idle or unneeded licenses, and that can help you reduce your spending. You can work with your team and learn more about, try to identify some of the license that you don't need, but you're paying for it still. All right, next one is cloud native design. Talk about cloud native a lot. So replace your existing cloud systems with more cost efficient ones to leverage the cloud specific capabilities. An example of this can be, you can design a system like, just taking an example of what Matt mentioned, with auto scaling, so you can ensure that you only pay for the servers that you are using. So that was a good point raised by Matt. So auto scaling, yeah, something you can try. And also your design, when you talk about cloud native design, it should, when we talk about cost optimization, it should balance cost optimization along with performance and some other considerations that are, again, based on your organization's priorities and objectives. So for example, like talk about optimization, then what's a good example? Maybe a fast DevOps pipeline in the cloud might not reduce your costs, So think about your organization's priorities. Okay, the hidden costs with like some of the hyperscalers, so make sure you take note of that as well. And you may get like a reasonably priced storage, and it's like even free to upload and stuff like that. Let's say we talk an example of AWS, but when you get it out, you have to pay enormous costs. So yeah, if you talk about the market share that let's say the big three have, can anyone like take a guess? What's the percentage? As of last year? Anyone? It's around, as you can see, 200 billion, but close to like more than 60% or something like that. And if you can see, around 65% market share. So before, when we talked about the survey, we're like, okay, is this a dangerous place to be? Because 82% cloud spend with like large companies, and so much we have with like so few. Is there a risk associated with it? Because the previous point that we mentioned, why folks pick the like larger providers compared to like smaller providers, is like they're more reliable, but they're not immune to outages, because so let's say a 16-hour outage of Office 65 equivalent in data center overheating, Cloudflare outage, and all these other things. So definitely something to consider. And price increases. Recently, we saw a global wave of folks increasing prices. In the news recently, there was like Linode increasing their prices as well. And it's not like you're saying don't go with it, because it's ideal for, let's say, large enterprises. So when we talk about whom is it suitable for, the big three or whatever, you have, let's say, more knowledge in specialist areas. Let's say training certifications are necessary, safety numbers, on-call work, the need for more services because they have, let's say, so many services, but not everyone needs those. If you have deep pockets, and if you need basically enterprise support, it comes with a big price. So that's one more thing. You can also evaluate smaller private providers, because you probably don't need hundreds of products. And in the survey, around 20% folks, said that they're using more than 15 services, 34% less than 5. You can also save money, no egress charges, predictable billing. Complexity is reduced considerably, which is ideal for smaller teams, and performance and efficiency can be improved. Get a more personalized service at not a cost, and enhanced SLAs and things like that. So there's no like one size fit all thing. So we talk about hyperscalers, we talk about like smaller providers and things like that. I think you can mix and match, and you can take a multi-cloud approach, which I'll talk more about later, and how that can help you. But talk about, let's say, Kubernetes multi-cluster. On the other hand, it refers to creating like multiple clusters when you're running workloads, and defining like resource isolation, continued availability, and flexibilities and things like that. So how can this help you in reducing the cost? Because the number of nodes that are running in a cluster, that is actually critical for cost optimization. Therefore, it's important to ensure that your team is running the right size, the number and the type of node in your Kubernetes cluster, so you can manage the node density. You can maintain pod sizes, so you can manage the cost of your Kubernetes clusters, reduce the resource requests and the limits that can be used to avail enough resources for optimal performance, so you don't have that much of wastage. Auto scaling, which I'm not going to repeat because we already talked about that previously. And if you talk about multi-cloud, I think this is something ideally you can get started with. It's a good point, because it prevents vendor lock-in, can take the best of all worlds. And some organizations, they seek out multi-cloud solutions to avoid vendor lock-in. So highly emphasizing on that point. Additionally, the administrative hassles of switching between platforms and paying for like network traffic might and like some people would be like, okay, it may be difficult to manage, multiple clouds and things like that. But ideally, if we talk about, should you take a multi-cloud approach? So the good point around here is that you don't put all of your eggs in one basket. And again, as I mentioned, no one size fits all. You can have varied workloads with performance and cost and environment type. Different departments can have different needs. You can use some SaaS tools as platforms and things like that if you want, cost efficiency and things like that. Multi-tenancy. So the phrase multi-tenant cloud, it refers to when you have like a cloud computing architecture that allows customers to operate in like a shared environment. The benefit is that cloud vendors can provide increased storage and greater accessibility for a lower price compared to a single tenancy. A multi-tenant architecture also provides high levels of agility and scale. So capabilities can be rolled out across all customer locations easily. And further, you can also use multi-tenant architecture, can manage multiple platforms simultaneously. And multi-tenancy eliminates the need for individual users to manage infrastructure and handles updates and maintenance, especially if they are using a managed service provider to act as a single pane of glass. So cost benefits, like most importantly, an organization who needs to access multiple cloud providers with a range of products will save money by working with the, let's say, a multi-tenant managed service provider compared to working independently with a single vendor, let's say one particular cloud provider. Because a flexible approach like this, it's perfect for organizations that are growing rapidly, and especially as a provider that simplifies management and saves time with multi-tenancy. So here you can see about if we talk about FinOps. So having like a dedicated FinOps like a role in your business role in your organization, and having cost as a first class metric. And if you talk about how it works, basically, so tying the financial and engineering teams together, you figure out the key metrics like the project cost and the team cost, and figure out the overall budget. And when we running out of time here, so sorry about that, but talk about parameter tuning, then some of the things that since we're talking about Kubernetes cost monitoring, so some of the things you can watch out for if you talk about, let's say, compute. So delete compute and volume stays and new instant types and things like that. IP addresses and unattached data transfers, NAT gateways for network. For storage, I mentioned this previously as well, unattached PVCs and extra volumes and snapshots and log retention. And for Kubernetes, we talked about autoscaler and all these other things, so you can check it out as well. With Kubernetes, with Kubernetes comes complexity. So, an additional layer of abstraction, if you may have, you can get the node cost. But if you talk about workloads, then as Matt was mentioning previously, around, let's say, auto-scaling features and monitoring and observability solutions, if you need more granular things. Some more recommendations you can check out include, let's say, you can check out AWS Cost Explorer. If you use that, you can have budget allocations per project, you can set up alerts, you can make sure you use, let's say, logs and metrics, and that the data does not populate, because I asked this question to Matt in his previous talk as well, and there was a great answer for that. When you're working with dealing with large amount of data from various resources, and complete policy training as a part of FinOps. So yeah, that was basically about it. And one more thing I want to mention is you build a culture. You can do this by promoting the idea of cloud cost within the organization, and making sure that it's easy for everyone on the development team to also see and understand actual costs, keeping cost as top of mind as your engineering decisions are made. And yeah, so in the end, it's just more than just tools. So yeah, building a culture and all these other things. I have a lot of things to share, but we're running out of time. So I want to talk about, let's say, unit costs, benefits of, let's say, cost per customer. So figure out, let's say, understand the pod cost and the shared cost. You tie it on together. So price per unit multiplied by consumed unit per customer, plus the number of dedicated pods, you get customer costs. So it gives you a good understanding of which customer is, let's say, more profitable and things like that, and easily explains why your bills went up and if that was a good thing. So a lot more we can talk about: cost per app, cost per team, revenue, cost per unit, cost per R&D, cost per feature, and how much are legacy decisions costing us, how much is it going to cost to build this feature, and things like that. Cost per cloud service, So a lot of things to consider, but yeah, ideally it all starts with monitoring. And once you have a dedicated monitoring system in plan, you will be able to see where you're spending most money and whether it's useful and things like that. I'd like to end this session with the quote by Albert Einstein that genius is making complex ideas simple, not simple ideas complex. And ideally, just don't be afraid to talk to customers. The best software engineers are the ones who work with the customers to solve their problems. And sometimes, sometimes you can sack a half year of development time just by learning that you can solve the customer's issues with a single line of code. And I think the best engineers are creating solutions for the real world problem with their customers, identifying what the customers needs are. So talk to people, talk to your customers, and it's also a good way to start. But yeah, that was my talk, and thanks a lot for joining. Don't see any new questions, but it's being recorded, and it's really a pleasure hosting with you, Matt. And we're going to have the talks recorded so you can watch it later on YouTube. And yeah, this was great. A lot of fun. It was a nice topic.
Thank you, guys. Have a good one, everybody.
Thank you. Bye.